Hello, this is Mrs. Huntley. This is Module 5, Lesson 2, Comparing Functions. You should have your packet that has the front cover that says Functions very large on it. And I would like you to open in that packet to page 6, which should look like this. Please add the essential question at the top of the page, how do I compare functions? And then let's look at the fill-in-the-blank notes together. We can compare functions by looking at their properties, such as their slope or rate of change. Remember, the word slope and rate of change are synonyms. To find the rate of change, we can use the slope formula or compare the ratio of rise over run. So let's look at the slope formula real quick. I just want to remind you of what it looks like. So let me get a pen. So our slope formula, that's our m, is equal to y2 minus y1 over x2 minus x1, or compare the ratio of rise over run. We also learned, we also learned the what we call the Larkin L, where you make a large L and you have one ordered pair here, and the second ordered pair, we'll just call it x2 and y2. There, they straddle the line. You subtract down, and your change in y goes on the top one, and your change in x goes on the bottom one. So this comes around that way. Okay? So hopefully you're remembering that. This was all in Module 4. We went through it. We've been working on it, since December? So hopefully these are all things that are familiar. So the next part, practice finding the rate of change in the following examples. This should be review. We have done this many times. So looking at the equation, and remember this is in slope-intercept form, so y equals mx plus b. When you're identifying the slope, you're just picking out what is in the m spot. So our rate of change, our slope on this one is 2/5. Okay. Number 2, we've got 2 points. Here's our x. Here's our other x and our other y. So we can call this one x1 and y1, this one x2 and y2. It doesn't matter which one is 1 and which one is 2. Remember this? So if we're using the Larkin L method, I would have them straddle the line. I would just grab some points. So I'd have 5 and 7.5. That's my x and that's my y of my first set. And then 6 and 9. I'm going to subtract down. Ooh, I don't know why that happened. I'm going to subtract. Oh boy. I must be hitting something that's making it go a little goofy for me. So 7.5 minus 9 is going to be a negative 1.5. And 5 minus 6 is a negative 1. And you all remember that a negative over a negative makes a positive, and anything divided by 1 is going to be itself. So this is going to be a positive 1.5 slope or rate of change. So I'm going to put that in there. Those of you that really like the formula rather than the Larkin L, I'll do the slope formula real quick for you just to remind you. So I'll take my 9 minus 7.5 over 6 minus 5. These just happen to stay positive because of the way I grabbed the numbers when I was doing the Larkin L. 1.5 over 1, so that's going to be 1.5. And again, either method that you use, you should get exactly the same answer. Now, when it's in a table, we have, again, we could use the slope formula. We could use the Larkin L. The third thing we could do is do change in y over change in x. So if I figure out my x's, 5 going to 7, that's going to be a plus 2. 7 going to 9, that's a plus 2. So my x's are going up by plus 2 each time. My y's, negative 5 going to negative 11. Let's see, it's getting more negative by how much? It's getting negative 6. See if it's staying consistent. Negative 11 minus 6 is negative 17. So my rate of change, oh my goodness, I wrote the wrong thing. So negative 11 minus 6, minus 6, there we go, is negative 17. I apologize. Getting used to the new technology and just on the struggle bus this morning. So my change in y, how is it changing each time? It's going down 6. So my change in y is 6. My change in x, I'm sorry, negative 6, is 2. So negative 6 divided by 2 is negative 3. So my rate of change here would be negative 3. Again, you could, if you were listening to me and you're like, I have no idea what she's doing, go ahead and use the Larkin L, or go ahead and use slope formula. This is your x, this is your y of 1 point, this is your x, this is your y of another point. Okay? Finding rate of change or finding slope from a table. Again, we've been doing this one for a long time. Find your points. What's your rise? I'm going up 1. So my rise goes on top. How many am I going over? 1, 2, 3, 4. So this is a 1/4 rate of change or slope. Okay. Use your skills or knowledge of rate of change to help you compare the following functions. So Ty sells signs in a monthly craft fair. He can make 7 signs every 2 hours. So 7 signs every 2 hours. So I'm just going to say Ty does 7 signs every 2 hours. Okay. His friend Harrison helps him make signs, and the rate at which Harrison makes signs is in the table below. So we've got in 0 hours he makes 0 signs, in 4 hours he makes 15, in 8 he makes 30, in 12 he makes 45. So again, we've got a table similar to the one that we have up in problem 3. So I have options of how I can solve this. I can, of course, use the Larkin L. I can use the slope formula. I can do change in y over change in x. But I want to draw your attention to something. This is a proportional table. I know it's proportional because when x is 0, y is 0. I've got that point of 0, 0 there. So I could take my signs, 15, and divide it by the number of hours and figure out how many signs he's making per hour. Or I could say his slope. So this is Harrison. His slope is 15/4. And then I can see how many signs per hour that is by doing the division. If you're like, well, why does that work this time and it doesn't work every time? It's totally because it is a proportional table, and I know it's proportional because of this 0, 0 over here. If you wanted to just do the change in y over change in x, because that's what we've been doing, or do the Larkin L, absolutely, go ahead and do that. I just wanted to show you other methods here. Okay? So comparing 7/2 and 15/4 is kind of difficult. I'm looking at that and going, oh gosh, I could get a common denominator here, and it wouldn't be that hard, or I can do some division. If I do 7 divided by 2, I'm going to get 3.5. So what does that mean? It means Ty makes 3.5 signs per hour. If I do the division for Harrison, 15 divided by 4, that's going to be 3.75. Again, signs per hour. So how do I answer the next question? Who is making signs at a greater rate, and how do you know? Well, Harrison is making signs by comparing the slope. I can see .75 signs per hour, and Ty makes 3.5. Let me make this a little smaller. Okay, so that's my answer. Harrison is making signs faster. I'm comparing the slopes. I'm always going to compare the slopes to see which one has a faster rate. Okay, after 12 hours, what would be the difference in the number of signs that each friend has made? Now, you could, at this point, figure out how to write an equation from this table. When x is 0, y is also 0, so it's going to be a proportional equation. And I'm only introducing this right now because we've done things like this before. This is actually a lesson that's coming up in a couple of days. But if I were to write this equation for Ty, it would be y equals 3.5 times x, and x would be the number of hours. Again, for Harrison, it would be y equals 3.75 x. If you're going, why can't we just multiply it by 12 hours? Exactly, that's what we're doing. For Ty, we'd take 3.5, because he can make 3.5 signs per hour, multiplying it by 12 hours. Grab your calculator and see how many signs he can make in 12 hours. I get 42. Do the same thing for Harrison. I'm just going to say, hey, H, 3.75 times 12 hours. Again, grab your calculator, plug it in. I get 45 signs. Let's see, did we answer the question? After 12 hours, what would be the difference in the number of signs that each friend has made? Now, difference means I'm going to subtract them. Harrison makes 45. Ty makes 42. The difference between 45 and 42 is 3. So Harrison makes 3 more signs than Tyler does in 12 hours. Okay. Hopefully this is all kind of a review and you're going, okay, this is really easy, Mrs. Huntley. I'm not understanding why we're learning this again, because this is very familiar. It's very similar to what we were doing before. Page 7. Julie's family is filling up a pool in her backyard. The equation y equals 5.2x plus 8,400 or 8,400 can be used to show the rate at which the pool is filling up with water, where y is the total amount of water in gallons and x is the amount of time in minutes. Her neighbor, Elena, is also filling up their pool as shown in the table below. So their pool, what this all means, these are our minutes going across the top, and these are the gallons of water. So before they start filling again, there's already 7,850 gallons in the pool. So this is not a proportional relationship. I cannot just take my y's and divide them by my x's because it's not going to be proportional that way because I don't have that 0, 0 at the very beginning. Again, hopefully that's a reminder to you. Okay, so they want to know who is filling up at a faster rate and how you know. We're going to have to find the slope or rate of change and compare. Okay. So finding the slope for Julie is pretty easy. For Julie, right here, 5.2 gallons per hour. Okay. For Elena, we have got to either do the Larkinell, the slope formula, or figure out the change in y over the change in x. Okay, so let's go ahead and do change in y. Yeah, I don't know. I'll do it both ways. I'll do change in y. So 7,850. What am I adding to it to get to 7,864.4? How could I figure that out easily? Well, I could grab my calculator and actually plug in 7,864.4 and subtract 7,850. When I do that, I get 4.8. Okay? The change in y, 0 plus 3 is 3. So my slope for, oh, I did this wrong. I did this wrong. I apologize. I read something wrong because I wasn't actually doing it. Hang on, let me back up here. Hopefully you didn't write in pen. Let me back up here. Let me actually, because I wrote something down and I didn't read my writing well. See, you write sloppy, you hurry, and what happens? You make silly mistakes. Now I've got a silly mistake on video. Let's see, 7,864.4 minus 7,850 is actually 14.4. This is actually 14.4. And then when I find the slope here for Elena, my change in y is 14.4. My change in x is 3. When I do that division, 14.4 divided by 3, this is where I get my 14.8. And it's 4.8 gallons per hour. Okay? So which pool is filling faster? The one that has a faster rate of change. So Julie's pool is filling faster. How do I know? She's got a higher rate of change. I'm going to say ROC, rate of change, okay? Next, compare the slope in each of the equations below. Circle the equation that has the greater rate of change. Show all work. So we've got two equations here, and they want to know which one has a greater slope. So I'm going to say rearrange both equations into slope-intercept form. Again, this should be review. I'm trying to get the y all by itself. So I'm going to add 9x to both sides of the equal sign. So 3y is left on the left. 9x plus 27 is on the right. Divide by 3. Divide by 3. You should get y equals 3x plus 9. Okay. I really like that that keeps happening, and I don't know how to not make it happen. So 3x plus 9. Okay. Would you please pause the video and rearrange the other equation, and then we can compare the slopes together. Pause the video if you haven't already. Come on now. Okay, so I got y equals 3/4 x plus 6. So I need to look at my slopes. So I'm looking right here. Oh, I don't know why that didn't change. Looking right there. Which one is greater? 3 is greater than 3/4. So this is my greater rate of change, this equation. Okay? Okay, now we have looking at it two different ways. We've got a slope in an equation, and we have some ordered pairs which we have to find the slope of. So go ahead and either do, I don't care whether you do the Larkin L or if you do slope formula. I'm going to quickly do the Larkin L, and I'm going to choose, you can choose any points that you want. I'm going to choose this point and this point. Why? These are whole numbers, and they're going to be easier for me. So I'm setting up my Larkin L. 5x goes on one side, the y goes on the other of the same point. 3 goes on one side, 3.8 on the other. I'm going to subtract down. I get 1.2. 5 minus 3 is 2. Ooh. How do I compare 3/5 and 1.2 over 2? I'm going to do a division here. 1.2 over 2. Put that in my calculator, I get 0.6. If I take 3/5, that's my slope up here, put it in my calculator, I'm going to get 0.6. So which one has a greater rate of change? They're the same rate of change. Now notice, guys, we had to have the same format. We either have to have things that we can look at and decide which one is greater just by looking at them, or we have to put them in decimal form and order them that way. So here's 0.6, here's 0.6. That's how I know they have the same rate of change. Okay, I know I'm running long, and I apologize for that, but I do kind of want to get through this entire lesson. So let's just take a look at the last one. I'll go as quickly as I can. Reese and Kevin have been working together to try and lose weight. Reese's weight loss can be modeled by the equation y equals negative 4x plus 203, where y is his total weight and x is the number of weeks he's been working out. Okay, so he's losing, what is this? Negative 4, Kevin, is negative 4 pounds per week. That's his rate of losing weight. All right. Reese. No, I'm sorry, that's Reese. Oh my goodness. Maybe I should just stop right now because I'm making all kinds of mistakes today. So this is Reese's weight loss is 4 pounds per week. Kevin is shown on the graph. So Kevin is starting off at 200 pounds, and let's see, he's going down 20, because 180 to 200 is 20, over 1, 2, 3, 4. So for Kevin, his rate is negative 20 over 4. Now negative 20 over 4 is 5, negative 5. So he is losing 5 pounds per week. So who's losing at the faster rate? That would be Kevin. Versus Reese, who is losing 4 pounds per week. Okay, that concludes today's lesson. So when you're looking at two scenarios, two equations, two different situations, you're going to look at the rate of change or the slope to compare them. The higher the rate of change, the greater that they're losing weight, or that they're filling pools, or that they're making signs, or whatever it is. That's how you order it. So you have to read the question, and oh, it says explain your reasoning here. I compared the rates of change. Okay, I compared the rate of change. Oops. And that's exactly what you're doing in every situation. That's what you're going to do. Now, what I want to do really quick, because I'm not here. Oops. Oh my goodness, I am so on the struggle bus. Oh, okay, rate of change. There we go. What I want to do really quick, because I'm not here to advise you. And if I am here, that's because I'm reusing a video. But I created these videos because I knew I was going to be out of class. The homework page, which we're going to do in class tomorrow, what you're doing is you're finding the rate of change in all of these situations, and you're going to put them here. Okay? Then after you have them all in the table for A through H, then you're going to rank them, like put them in order for where 1 is the smallest rate of change and 8 is the greatest rate of change. So that's what you're going to do in class. Do not do this for homework. If you're watching this video at home, that's what you're going to be doing in class. I just wanted to explain it to you. Same thing with this page. You're going to be comparing all 3 scenarios and then answering the questions. The only thing I don't like about this is these questions are so tightly packed together. You're going to be like doing your work around the sides of the page and then answering just with a single word here, but you've got to show your work. Okay? Have a great night, and I will see you in a few days or tomorrow.